Today we're going to talk about converting unit rates. The relationships among some commonly used customary and metric units of measure are shown in the tables below. Each of the relationships in the tables can be written as a unit ratio. Like a unit rate, a unit ratio is one in which the denominator is 1 unit. Below are 3 examples of unit ratios: 12 inches to 1 foot, 16 ounces to 1 pound, 100 centimeters to 1 meter. Additional customary and metric conversions can be found on your STAR math chart. The numerator and denominator of each of the unit ratios shown are equal. 12 inches equals 1 foot, 16 ounces equals 1 pound, 100 centimeters is equal to 1 meter. So the value of each ratio is 1. When converting unit rates, you include the units in your computation. Including units of measure as factors is called dimensional analysis. There are 2 important concepts we must understand when converting unit rates. The first is that we are not setting up proportions, so our units do not have to line up. The second is cross-canceling or dividing out common factors. For example, 1/3 times 3/5. I would check my diagonals to see if there are any common factors. I have a numerator of 3 on the right and a denominator of 3 on the left. Common factor is 3, so both of those cancel each other out and they become 1s. Then I would multiply with what's left and get 1/5. Another example would be if I had 5/5. Common factor is 5. They become 1s when you divide both of them by 5, which would be equal to 1. In converting unit rates, we will be factoring out common units. Let's take a look at this first example. A remote control car travels at a rate of 10 feet per second. How many inches per second is this? The first thing we want to do is write down the unit rate that is given to us, which is 10 feet per second, or 10 feet in 1 second. Then let's look at what they're asking for. They want to know how many inches per second this is. Now let's take a look at what I want to get rid of. My unit rate is feet per second, but they want to know inches per second. So what unit am I trying to get rid of? I'm trying to get rid of feet because they no longer want feet, they want inches per second. In order to do this, I need to realize that if I multiply by something with feet on the bottom, those feet are going to cancel out. Now, what am I looking for? I'm looking for inches. Do I know a unit ratio that has inches and feet in it? In this ratio, my numerator and denominator must be equal. So do I know something that I can put in there that makes those two equal? Well, I can put in, I know that I have to have feet, so I'm going to put 1 foot here. And I know that how many inches equal 1 foot? 12 inches equal 1 foot. Next, I'm going to cancel out any common units in the diagonals, and I have feet, diagonal from feet, so they cancel each other out. Inches and seconds are not the same, so I'll leave them. And now I'm going to combine what I have left on top and on bottom. And now I'm going to work it out. 10 times 12 is 120 inches. 1 second times 1 is 1 second, and I come up with 120 inches in 1 second, which answers the question, how many inches per second? Let's try another example. A swordfish can swim at a rate of 60 miles per hour. How many feet per hour is this? So first, let's write our unit rate. 60 miles per hour, so over 1 hour. Now let's identify the question that they're asking. How many feet per hour is this? So I'm going from miles per hour to feet per hour. So what do I want to get rid of? I want to get rid of the miles. So miles have to be diagonal from miles. So I need to know something that's equal to 1 mile. Do I know how many feet are equal to 1 mile? Yes, 5,280. Now my miles can cancel out. I'm going to multiply what's left. So 60 times 5,280 feet over 1 hour times 1. When I multiply 60 times 5,280, I get 316,800 feet. And 1 hour times 1 is still 1 hour. Did I answer the question of feet per hour? 316,800 feet in 1 hour. Yes, I did. This last example requires an extra step. Marvin walks at a speed of 7 feet per second. How many feet per hour is this? So we're looking for feet per hour, and what we get is 7 feet per second. So I want to go from seconds to hours. What do I want to get rid of? I want to get rid of seconds. So I'm going to put seconds diagonal from seconds. Now I don't know how many seconds are in an hour, but I know that there are 60 seconds in 1 minute. Now my seconds would cancel out my seconds, and what I would end up with would be feet over minutes. So feet per minute. That's not what I'm looking for. I'm looking for hours. So I have to go one step further, and I know that there are, I want to get rid of my minutes, and I want hours. And I know that there are 60 minutes in 1 hour. Now my minutes cancel out my minutes, and now I'm going to combine everything that's left. So I have 7 feet times 60 times 60 over 1 times 1 times 1 hour. When I multiply 7 times 60 times 60, I end up with 25,200, and my units left on the top is feet. 1 times 1 times 1 is 1, and my units left on the bottom is hours. So 25,200 feet in 1 hour, and that answers the question of how many feet per hour.